Understanding HCI. The main tactic of HCI in systems analysis and design is to repeatedly elicit feedback from users about their experiences with prototype designs, which could be screens, forms, interfaces, and the like, refining the design based on the suggested changes, and trying them with users again until the design is acceptable and until it is frozen by the analyst. How fit affects performance and well-being. A good fit between the HCI elements of the human, the computer, and the task that needs to be performed leads to performance and well-being. Performance. The performance is also efficient, because the analysts are using an automated tool with which they are familiar. They can work rapidly, with good results. The task fits the objective, which is to create high-quality data flow diagrams to document a system. Well-being. The task fits well with the analyst, the software, the objective, and the computer. Notice that the analysts are working in an environment where they are physically comfortable, are psychologically stimulated to be creative, and can be productive. Also, each analyst's work is valued by peers and clients, as well as valued monetarily by the employing organization. The technology acceptance model and attitude. The technology acceptance model also points out the importance of whether users find a system useful and are thus motivated to use it. Since this is an important HCI concern, we can measure whether the information technology is found to be useful by examining whether the system provides support for an organizational member's individual tasks. Usability. Nielsen and Mack, 1994, and Nielsen, Malik, Snyder, and Farrell, 2001, have published usability heuristics, or rules of thumb, based on thousands of usability tests of interfaces and, later, tests of e-commerce websites. They include visibility of system status, match between the system and the real world, user control and freedom, consistency and standards, error prevention, reconnection rather than recall, flexibility and efficiency of use, aesthetic and minimalist design, help that users recognize, diagnosis and recovery from errors, and help and documentation. Figure 14.2. A form may be used to survey users of prototypes on key usability and ergonomic factors. Designing for the cognitive styles of individual users. One important consideration is that data, particularly data used for decision-making, are made available in different forms so that users with different cognitive abilities can make sense of them. It is also imaginable that the same person wants different types of presentations at different times. For example, suppose a manager wants to compare inventory held at different stores in a region. A graph can present the data very effectively. Pivot tables. Gives users greater control over how they look at data in different ways within a table. Pivot tables allow users to arrange data in a table in any way they choose. An example of a pivot table template created in Microsoft Excel is shown in Figure 14.3. Visual analysis of database. Innovative visual displays of data have existed for quite some time, even as early as the 18th century. One example is Tableau Software's product. Using an approach similar to the pivot tables we saw in Microsoft Excel, Tableau allows the user to drag and drop variables onto either a row or a column, and they appear on the graph. Physical considerations in HCI design. Touch. It is all about the input devices that are used to enter data in a system. Hearing. In an office, noisy dot matrix printers and phone conversation will lead to overload hearing, and personnel iPod players or noise-canceling headphones will diminish their skill of work. Vision. Factors such as length of the distance from display to the person performing a task, the angle of the display in relation to the person viewing it, the size and uniformity of the characters, the brightness, contrast, balance, and glare of the screen, and whether a display is blinking or stable can all be designed to standards established through ISO and other national and international groups. Natural language interface. Natural language interfaces are perhaps the dream and ideal of inexperienced users, because they permit them to interact with the computer in their everyday, or natural, language. Permit users to interact with the computer in their everyday or natural language. Implementation problems and extraordinary demand on computing resources have so far kept natural language interfaces to a minimum. Q&A interface. In a question-and-answer interface, the computer displays a question to the user on the display. The computer displays a question to the user on the display. The computer acts on that input information in a pre-programmed manner. Users unfamiliar with applications may find question-and-answer interfaces most comfortable. Menu interface. A menu interface provides the user with an on-screen list of available selections. Provides the user with an on-screen list of available selections. Can be put aside until the user wants to use them. Can be nested within one another to lead a user through options in a program GUI menus. Form fill interfaces, input/output forms. Form fill interfaces consist of on-screen forms or web-based forms displaying fields containing data items or parameters that need to be communicated to the user. On-screen forms or web-based forms displaying fields containing data items or parameters that need to be communicated to the user. Command language interface. A command language interface allows the user to control the application with a series of keystrokes, commands, phrases, or some sequence of these three methods. Allows the user to control the application with a series of keystrokes, commands, phrases, or some sequence of these. Affords the user more flexibility and control. Require memorization of syntax rules. May be an obstacle for inexperienced users. Graphical user interfaces. Provide users constant feedback on task accomplishment. Continuous feedback on the manipulated object means that changes or reveals in operations can be made quickly without incurring error messages. Other user interfaces. Other less common user interfaces are growing in popularity. They include pointing devices such as the stylus, touch-sensitive screens, and speech recognition and synthesis.
Guidelines for dialogue design, meaningful communication so that the computer understands what people are entering and people understand what the computer is presenting or requesting. With this, one should consider the following: the system should present information clearly to the user. Users with less skill with a computer require more communication, and lastly, easy-to-use help screens. Minimal user action. Keying is often the slowest part of a computer system, and good dialogue will minimize the number of keystrokes required. You can accomplish this goal through the following. Keying codes instead of whole words. Entering data that are not already stored on files. Supplying the editing characters. Using default values for fields on entry screens. Designing an inquiry, change, or delete program so that the user needs to enter only the first few characters of a name or item description. Providing keystrokes for selecting pull-down menu options. Use radio buttons and drop-down lists to control displays of new web pages or to change web forms. Provide cursor control for web forms and other displays so the cursor moves to the next field when the right number of characters has been entered. Any combination of these 8 approaches can help the analyst decrease the number of keystrokes required by the user, thereby speeding up data entry and minimizing errors. Feedback for users. All systems require feedback to monitor and change behavior. Feedback compares current behavior with predetermined goals and gives back information describing the gap between actual and intended performance.